Okay, ladies and gentlemen, let's take a look at some examples from page 317. Thought I'd go through some of your homework examples. That way you can see them worked out for you. Now, let's start with some multiples of 3. So I have number 24. Number 24 says secant x cotangent x minus sine x. Now, if we're taking a look at something like this, our directions are to simplify. So if I'm going to simplify this, I'm going to make it more simple. Now, the problem with simplifying is you're not exactly sure where to stop. Now, in future sections, we're going to say, here's the beginning point, here's the ending point you got to get from here to here. But in this case, we're just making it more simple. Well, my problem is I have secant, cotangent, sine. I got way too much stuff. Let's just change it all to sines and cosines. So let's go 1 over cosine x times cosine x over sine x minus sine x, and I did that by reciprocal and quotient. So by reciprocal and quotient. Now, with that, I can say, aha, I see something. Cosines, they go. 1 over sine x equals, not equals, minus sine x. Well, here's the question. Is that by simplify or reduce or something like that? Is that more simple than when I started? The answer is yeah. I went from 1, 2, 3 different functions in 2 parts to 1 function in 2 parts. Well, that's not so bad, but maybe I can get better. What if I keep on trucking? Well, anytime I have fractions and I have an add or subtract sign, why don't I find common denominators? So 1 over sine x equals sine, not equals, minus sine squared x over sine x. And that is by common denominators. Okay, fine. So let's go ahead and say, well, 1 minus sine squared x all over sine x. Well, at least it's now one fraction. I guess it's a little more simple, but this is by subtraction. But why can't I just do this? Wait a minute, 1 minus sine squared, that's one of our fancy ones that we're supposed to remember. Cosine squared x over sine x, and that is by Pythagorean theorem. Now, at this point, I'm like, you know what? I'm done. That's as far as I'm going. Is it more simple than the original? Yes. Is it significantly more simple than, say, this? I don't know. Maybe it's at least one fraction, not two, but now it's 2 functions, not 1. So I don't know. Any of this here would be good. Here would be okay. This would be better. So that's what we have for simplifying. Now, let's take a look at number 27. Actually, I'm not going to look at 27. That's exactly what we did in class. So 27, you've already seen how to do. Now, let's go to 30. If I talk about number 30, that's going to be cotangent x minus cosecant squared x cotangent x. Now, some of you say, well, why don't we just turn to sines and cosines like last time? Okay, we could. If I were going to do it, method 1 for me would be, I have a cotangent in both places. So why don't I just take a cotangent x out, leaving 1 minus cosecant squared x? And that would be by factor. Now, I say, ooh, wait a minute. That guy, that's nice. Because that looks like one of my things. But what we actually have is we have cotangent squared x plus 1 equals cosecant squared x. That's our theorem. Now, if I want to turn this, I need a minus. So if I subtract 1 from both sides, cotangent squared x equals cosecant squared x minus 1. That looks very similar, but we're still backwards. This is one of those tricks that unfortunately this book uses a bunch. Now, it's not that big a deal, but it's kind of annoying. They're backwards. To turn them around, multiply both sides by -1, or divide both sides by -1, whichever way you'd like to think about it. So negative cotangent squared x equals 1, because negative times a negative is a positive. Negative times a positive is a negative. And so now 1 minus cosecant squared x is negative cotangent squared x. So I have cotangent x times negative cotangent squared x by Pythagorean theorem. and put it all together, I have negative cotangent cubed x, and that is a lot more simple by simplify or multiply, whichever one you want to call it. So that's what I come up with right there. Now I said there are probably two methods. Let's do a second method. Let's change it to cosine x over sine x minus 1 over sine squared x, cosine x over sine x. And okay, that's not really any better. So this was method 1. This is going to be method 2. Now, at this point, we could say, well, okay, by reciprocal and quotient, there you go. We get those two. Now let's find common denominators, cosine x, sine squared x minus 1 minus a cosine x all over sine cubed x. And that's just by common denominators. Now, again, I have a cosine in each place factored out. Cosine x leaves sine squared x minus 1 all over sine cubed x. That is by factoring. Now, if you say, wait a minute, I recognize this better than I would have recognized this. Fine, but it's still backwards. Can I take a negative 1 out and say cosine x equal or times negative 1 times 1 minus sine squared x, and then that turns into cosine x, negative out front here, cosine squared x, which turns into negative cosine cubed x over, don't forget that sine cubed x, and so negative cosine cubed x over sine cubed x equals negative cotangent cubed x. This one's a little cleaner. There's nothing wrong with this one. And again, your answer would be factor out a negative 1, quotient property to put it back. Okay, I'll pick up a few more in the next video.